Our player can now move their ship around the game area, and it can't leave the bounds of the game. So now let's create shots for our player to shoot. First, let's begin by deactivating our player game object. This assignment won't involve the player's ship, and again it will simply be in the way. Next, create a new empty game object. Use Shift-Command-N on the Mac and Shift-Control-N on Windows. Rename the new empty game object Bolt. This will be a parent game object for our shot. We are going to separate the game logic from our visual effect of the shot. This will allow us to easily make new weapons with different visual effects by reusing the parent game object with the logic and replacing the visual effect layer. Reset the game object's transform to make sure it is at origin. Now, create a quad to hold our visual effect image, just like we did for our background. Rename the quad VFX, and reset the quad's transform. Now add the VFX game object as a child of Bolt. If we switch to the scene view, we can see the quad, just like the one we used for the background, is oriented in a way we can't see with our game view camera. Change the transform rotation X to 90. This will rotate the quad to face upwards towards the game view camera. See, it's perfectly face onto camera in the game view. Let's make this shot look like a laser bolt. So next we need to find artwork for our laser bolt. Open the Textures folder. In the Textures folder, find FX Laser Orange. When we created the background, we simply dragged the nebula texture onto the background quad and allowed Unity to make the material for us. This time, let's not drag the texture onto the quad, but let's create and assign the material ourselves. We want to create a new material in the Materials folder. When we create a new asset, Unity will create that asset in the folder we have focused or in the same folder as the asset we are currently inspecting. Select the Materials folder in the root level of Assets. With the Materials folder selected, click on the Create menu in the Project view and select Material. This creates a new material in the Materials folder. The new material is ready for a new name, so let's rename the material FX Bolt Orange. We want to add our texture FX Laser Orange to our material, but how? If we can't inspect the details of a material, its inspector may be collapsed. Click on the material's header to expand the material's inspector panel if it's closed. We can now see all of the fields for this material. There are two ways we can associate a texture with this material. The first is, in the material's main texture field, we can click on Select, and this will bring up an asset picker. At the top of the asset picker is a search field to refine the contents of the picker. Otherwise, we will get every possible object in the project that can go into this field. To associate a texture, we simply click on the texture we want. In this case, FX Laser Orange. If there is already an existing texture associated with this field and we want to remove it, we can select None. The other way is to simply drag and drop a texture into this field. Select Textures in the root of Assets, and drag FX Laser Orange onto our FX Bolt Orange material, and drop it into the main texture field. Both ways associate a texture to a material. If we look below the material in the inspector, we see a preview window where we can get a sense of how this material will behave in our scene. Now, to associate the material with the VFX quad, we can simply drag the material onto the quad. Now, if we look at the VFX game object and inspect the mesh renderer, we can see the FX Bolt Orange material has been added to the top slot of the materials array. Another way of associating a material with this game object is to populate these slots in the materials array by hand. We can simply drag and drop a material into the slots we need. If we swap to the game view, however, our laser bolt looks like a dull streak in the middle of a big black square. Not very flashy. What we need to do in this case is change the shader we are using. Just like when we created our background, diffuse is not the best shader choice for our weapon. For our weapon, we want the bright parts to add on top of the scene and the black parts to vanish. When looking at the VFX game object, we can change the shader on the material. Choose Particles Additive. With this shader, black has a value of 0 and will add nothing to the scene, and white has a value of 255 in all channels and will add full white to the scene. All of the other colors will be added on top of the existing background. This will give us a strong, hot laser bolt. We can also try Mobile Particles Additive. For our game, I don't see any noticeable issues with using the mobile shader. It looks just fine when we look in the game view. In many cases, mobile shaders can be used effectively in non-mobile games. In general, the mobile shaders will be more efficient with our game's resource budget, but in some cases may sacrifice either quality or control. The main control that we will lose by using this mobile shader is the ability to change the tint color, which we don't need on our laser bolt. With our visual effects set up, let's move on to setting up our logic. If we look at our bolt parent game object, we can see that it has no components beyond the default transform component. We will be moving these shots with physics. And, almost more importantly, we will be moving a collider in our game. Both require the rigid body component. So let's click on Add Component and select Physics, Rigid Body to add a rigid body component to the bolt game object. Deselect Use Gravity, as we don't want our shots falling down off of the game plane. Next, we need a collider to participate in collisions. Before we add one, however, we want to remove one. Click on VFX to show our quad. The stock quad is created with a mesh collider on it. We can disable the mesh renderer to see the green lines of this mesh collider. We don't need two colliders in this game object family, but more importantly, we don't want a collider that sticks out so far to the sides, beyond the image of our laser bolt. This would mean what looks like a near miss could cause a collision. On the Mesh Collider component, use the Context-Sensitive Gear menu and click on Remove Component. This will remove the Mesh Collider component from the VFX game object. Now let's add the collider component we want for our game. Click on the parent bolt game object, and click on Add Component. Select Physics, Capsule Collider. Now, this looks like a sphere, but it is not. It is a capsule. A capsule is defined by two spheres or hemispheres, one at each end, and the space in between. We are looking at a capsule that is as compact as possible, and there's no space between the two end caps. So, let's adjust the size of the capsule. We can reduce the radius dramatically, as our bolt is long and thin. When we do, we can see that the capsule is oriented differently from our bolt. The default orientation, or direction of a capsule, is along the Y-axis to accommodate humanoid characters. Let's change the direction to the Z-axis. Now it's oriented with our bolt VFX. Let's move into a top-down position. This view will help us size the collider correctly to our visual effect. Let's pick a radius that best matches our image. 0.03 looks good. Now let's reduce the height to fit our image as well. 0.5 looks good. We don't need the outer glow to have any physical effect in our game, just the hot core of our laser bolt. Before we leave this collider component, we need to set one other property. We need to select IsTrigger to make this collider a trigger collider. For more information on triggers and colliders, please see the lesson link below. With the basic component setup, we now need to write our custom logic. With the Bolt GameObject selected, click on Add Component and choose New Script. Name this script Mover. Confirm this choice to add it to Bolt. Let's file Mover into the Scripts folder and open it for editing. Again, let's remove the sample code. So what do we need to write? That depends upon what we want our laser bolt to do. We want it to move automatically when it's added to the scene. We want the laser bolt to have its own velocity, which we can set through the rigid body. So let's write void start. With start, the code we will write will be executed on the very first frame the object is instantiated. Let's continue with rigid body velocity equals, well, what? We want the laser bolt to travel along the z-axis towards the oncoming hazards the game will throw at our player. The local z-axis of an object is also known as its transform forward. So let's finish with transform forward. We will want some control over how fast our laser bolt moves in our game. So let's add public float speed. And let's multiply transform forward by speed. That's it. It's a very simple script. Save this script and return to Unity. We can see Bolt now has speed as part of the mover component we have just written. Our player is going to shoot many copies or clones of this shot, so let's save this game object as a prefab. The easiest way to do this is to drag the Bolt game object from the hierarchy view into the prefabs folder in Assets. Click on Prefab so we can see our Bolt prefab. Currently, we have full access to the components on this prefab, but note that the preview window is open. Even though we can scroll to see all of the components on a game object, if this preview window gets in the way, it can simply be dragged down and closed against the bottom. Let's set the speed value for our bolt. How fast was our ship traveling? 10? Our shots need to go faster than our ship, so let's try a speed value of 20. Lastly, we only want an instance of the Bolt game object in our scene when our player fires its weapon. So let's delete our working instance of Bolt from the scene. So save the scene. Turn off Maximize on Play if it's on, and enter play mode. To test the bolt, as we don't have any shooting code, we can simply drag copies of the prefab into the hierarchy window while the game is running. And they work as we expected. Off they go towards the top of the screen. These are our shots with their VFX and their logic. In the next assignment, we will write the code for our player to fire these in the game.